Hello fellow chemists, Jolly here again. Let's do another multi-spectra problem. This one is number 5. And again, let's start with that proton NMR. This one goes up to a 9. So number 1, I have an A, I have a B, I have a C, and I have a D. So I have 1, 2, 3, I have 4 peaks. I have 2, 4, 5, 6, 7. Oh, 7 hydrogens. So I have a nitrogen or a halogen. Okay, I have a nitrogen or a halogen. And this right here, that is very broad. Okay, that comes from hydrogen bonding. So that is probably an NH2. That is probably an NH2. This region right here, okay, this region right here is aromatic. So I also know that that's the benzene region. And I know there's 5 hydrogens, so it is mono-substituted. So it is mono-substituted. Whoa, I got a lot from that. Alright, now can I tell what these patterns are? That first one could be a triplet. I'm not going to fall in love with it, but it kind of looks like a triplet. That one kind of looks like a triplet too. And maybe a doublet on that one. Alright, so right now, I don't even need to get any more detailed. There's 1, 2, 3, 4, 5, 6, and 7. That actually is my molecule. That's actually my molecule. Alright, let's double check here. So right here, I would expect a doublet that integrated for 2, somewhere between 7 and 8. Right here, I would expect a triplet that integrates for 2, somewhere between 7 and 8. And this one would be kind of a triplet for 2, somewhere between, whoops, not for 2, for 1 hydrogen. Let me erase that. For 1 hydrogen, somewhere between 7 and 8. Alright, let's double check. Was there a doublet for 2? Okay. Was there a triplet for 2? Why, yes, there was. And was there a triplet for 1? Wow, and that was actually the splitting patterns too. So this is A. Let me see, A is the triplet. So A is the triplet that integrates for 2. So this one's A. The B and that doublet that integrates for 2, that one would be C. And then of course D is the nitrogen right there. Oh, we don't even need the other spectra, but let's go and confirm. Alright, we have an A, we have a B, we have a C, and we have a D. Beware the shadow peaks right there. Alright, so I have 4 peaks. So I have 4 uniques, and this right here is the aromatic world. Okay, that is the aromatic world. Oh, well, okay. So I know there is an aromatic, and there's 4 types of hydrogens, okay? Or sorry, 4 types of carbons. So I know there can't be many things on it, okay? So I have to have some kind of a symmetry. And that's what I can get from the carbon 13. All right, let's look over. Oh, look at that right there. That is an N, and there's 2 peaks, so there's an NH2. There's my sp3s. And I need some here, so those are my sp2s, and I have to have, oh, there's my combination bands. And right here, it looks like those are my carbon-carbon double bonds. Oh, look, I think there is an aromatic, specifically benzene, with a primary amine, which matches what we drew up there. Okay. I think that has to be my M+2, so I go back 1. So this is my molecular ion. That makes that M+1. And that's 90, 91, 92, and 93. So the molecular weight is 93, which means there has to be a nitrogen. It means there has to be nitrogen because it's odd. So 93 minus 14, and 93 minus 14, should never trust the math in my head, leaves us 79. Alright, and how many carbons can we get into 79? Let's try 6 carbons. And it's 7, and that would leave me 7 hydrogens. Alright, so let's try that. C6H7N. 2 times 6 plus 2 is 12, 13, 14. And remember, you subtract 1 for nitrogen, so it's 7 minus 1, so that's really 6. So 8 divided by 2 is 4. That always, well, no, I shouldn't say always, that is very indicative of a benzene. Okay? Oh, alright, well that matches. So let's go back up. C6H7N. Did we expect 7 hydrogens? Whoops, I went too far. Did we expect 7 hydrogens? Why, yes. Yes, we did. Okay. And so they all agree that it's the benzene with an NH2 on it. I just need to draw. All right. Now, I believe the one connected to the electronegative is A, and it does happen to be the shortest peak. All right. Now we kind of jump around B, C, and D. Now keep in mind, I'm not going just on how close to the NH2. They tend to be a little bit unpredictable in there. So if you put A, B, C, and D, absolutely no problem. But remember, I know something about the proton NMR, and I know that in this case, the B, okay, the 1 proton was a little higher than the 2, so I was trying to stay with that theme. Okay, and there is the structure all worked out for that question. All right, until next time, Jolly out.